Hi, my name is Jeff Warrock. I'm the meteorologist in charge here at the National Weather Service office in Wakefield, Virginia. Welcome to this final winter weather edition of Whether You Want to Know or Not. Today, we're going to be talking about the different types of snow, whether it's that nice, dry, powdery snow that you can go out and have some great skiing and sledding with, or is it that heavy, wet snow that's great for making snowballs and snowmen and building snow forts? It's all in the flake here on Whether You Want to Know or Not. So is the snow dry or is it wet? Again, is it a great ski day or is it time to head outdoors to build a snowman and have a snowball fight building those snow forts? So all this has to do with what we call the snow composition or the type of snow. The picture you see here comes from Louisa a few years ago, where we had a very heavy, wet snow that fell. It started out as a very wet, sticky snow that stuck to the trees and eventually transitioned over to a colder, drier snow. So we'll talk about what caused that transition and what causes that wet snow versus the dry snow. Again, it's all about the flake. So taking a step back, even when we are developing, sleet or freezing rain, they both start out as snow. So in the cloud layer is well below freezing, and you have snowflakes forming above our heads. But then what happened in a sleet situation is as the snowflake falls, it encounters a shallow warm layer, basically an area of temperatures that are above freezing, above the surface of the earth. And then those snowflakes partially melt. Now, they don't melt all the way. You have a water droplet, but then it maintains kind of this ice core. We call it an ice nuclei. And then as that raindrop with that little ice inside of it continues to fall, if it re-encounters temperatures that are well below freezing, now all of a sudden that the ice inside that water droplet reactivates and now it forms into a sleet pellet. And that sleet pellet hits the surface of the earth. So it really starts out as snow, melts into a water droplet that still has an icy center, and then eventually that freezes before hitting the ground, and that becomes sleet. Even freezing rain, a lot of the time, will start out as snow, so the cloud's frozen and it's cold enough to produce snow. But as the snow falls, it encounters a pretty deep, warm layer with temperatures, well above freezing for several thousand feet in the atmosphere. So at this point, what happens is the snowflake completely melts into a raindrop. And as that raindrop falls, right before it hits the surface of the earth, let's say in that last little thousand feet or so of the atmosphere, the temperature drops back down below freezing. And especially if the temperature near the surface of the earth is, let's say, in the mid to upper 20s, that water droplet is actually super cold. It's still below freezing, even though it doesn't have an ice center. And when that water droplet hits the surface of the earth, all of a sudden it instantly glazes into ice because the surface is so cold. So even freezing rain starts out a lot of the times as snowflakes above our head. They just melt on the way down and then refreeze on contact. So obviously to get snow, it has to be below freezing from the surface of the earth all the way up through the cloud layer. So the snowflakes form in the clouds, they fall through the atmosphere. The atmosphere stays well below freezing and the snowflake never melts. And of course, it reaches the ground as snow. And if the ground temperatures are cold enough, the snow will start to accumulate, pretty quickly. But again, what about the type of snow? What makes it that dry snow versus that wet snow? Well, it's all about the temperatures in the clouds. So, how does the snowflake actually form? The process in which the snowflake forms has everything to do with whether it's a wet snow or it's a dry snow. And again, it's all about the temperatures inside the clouds. So when we have water droplets in the clouds, the water droplets are what we call super cold. It's very, fairly pure water. And so the water will actually get below freezing before it freezes, below 0 degrees Celsius or below 32 degrees Fahrenheit. And so it's the particles that are dissolved inside the water droplet that activate, that actually cause, we call them nuclei. That's what actually causes the freezing to begin at certain temperatures. So if you have water droplets that have a lot of leaf bacteria in them, those water droplets will activate and they'll start freezing at about -3 degrees Celsius. Around here, we have a lot of dust and what we call common clay material, and that activates at around -9 degrees Celsius. So that means the cloud temperature of around -9 with a lot of clay dust in it. That's when you'll start to see those super cool water droplets starting to freeze into ice crystals to make snow. I'm closer to the coast. We may have a lot of salt, sodium chloride from seawater actually in the atmosphere. The activation temperature there is about -8 degrees Celsius, so maybe just a little bit warmer. But you can kind of generally tell about -8 to -9. That's the activation temperature for a lot of us here in the mid-Atlantic, where we really want to see the cloud temperature getting down to about -8 to -9 degrees Celsius or cooler to actually get those super cool water droplets to develop into snowflakes. So we do have what we call a snow growth zone when forecasters are trying to predict whether we're going to see snow, and especially a really efficient snow process where we could get several inches very, very quickly. And we're really looking at the cloud temperatures. So we're looking at a cloud temperature between usually -10 degrees Celsius and -20 degrees Celsius. This is what we call our snow growth zone. And if you look here, when the cloud temperature is about -5, notice how that most of the cloud at this point is still all liquid. It's super cooled water droplets. They're very cold water droplets, but they're not quite freezing yet. I mean, even about let's say -7 or so, the clouds are still mostly liquid. When you get to about -10 degrees Celsius, now you're getting into a mix where almost half the cloud is frozen water droplets and half the cloud is actually still water. And remember, that sodium chloride, the salt, and the clay particles in our atmosphere that are dissolved in the water, they activate at about -8 to about -9 degrees Celsius. So -10 roughly is kind of the beginning, the low end of where we start to see the snow growth zone. Now that goes up to about -20 degrees Celsius, where by the time you reach -20, notice that you see all this green here representing that most of the cloud at this point is containing ice or snowflake type particles. And so this is really when things are getting nice and cold. You're getting a lot of good ice generation. And so we're really looking for a lot of saturation or a lot of moisture running around -10 to about -20 degrees Celsius. That's the sweet spot for really good snow growth, especially here in the mid Atlantic. So that takes us to the actual snow growth process itself. And as you have a cloud up in the atmosphere, the cloud obviously stretches vertically through a range of temperatures where the lower part of the cloud may be around -5 to let's say -10 degrees Celsius. And the top of the cloud may be right around, let's say, that sweet spot of -10 to about, especially -20 degrees. So what ends up happening is that the lower part of the cloud has a lot of super cooled water droplets and some ice particles. But again, it's not cold enough to have just pure snowflakes, where the top of the cloud layer is cold enough to have pure snow and just pure ice crystallization. And so, because the top of that cloud is colder than the bottom part of the cloud. So now what starts to happen is that those ice crystals in the upper part of the cloud layer start to fall down towards the ground. And as they fall, they collide with super cool water droplets and other, warmer ice particles, and they start to kind of coalesce. They start to kind of stick together. As those snowflakes hit those super cooled water droplets, they causes even bigger snowflakes. It causes what we call glaciation. It activates the water droplets. And so this process occurs over a short period of time where it's snowing through the cloud layer, and as the snow falls, it's impacting other water droplets and other warmer snow crystals. And eventually, you have a glaciation process that cools the entire cloud layer. And the snow process that's occurring within the cloud really forces the entire cloud layer over to pure snow. Now, depending on the temperature inside the cloud, we can see different types of crystals form. So, depending on the temperature, when the water droplet freezes, it can freeze into different types of ice crystals. So, when the cloud temperatures are, let's say, right around about -5 to -10, so you're not in that sweet spot, you're just below the sweet spot. So, you have a lot of water droplets, but you also have some ice. And so, at these temperatures, you get more of these solid prisms, hollow columns, needles that start to form. And this can actually fall down to the ground in the form of what we call grapple. It's more like little snow, little teeny, like almost like little teeny snowballs. It'll look like little those little airsoft pellets, and they'll be very soft. And usually, when they hit the ground, they'll kind of shatter. And so, this is usually happening at a warmer process, about let's say -5 to -10. When you get into that sweet spot of -10, especially up to about -20, this is where we start to see more of the classic, like postcard type snowflakes forming. We call them dendrites. And you'll notice that all the snowflakes have six sides. So when you have an ice crystal form, no matter whether it's a plate or it's a dendrite or it's a needle, notice how all the snowflakes do have six sides to them. And then at -10 to about -20 degree cloud temperature, that's where you do have these classic dendrites form. And as they form, they expand, they take up more space, and so they allow for very efficient snowfall accumulation. And so you do have different types of snowflakes that do form at -10 to -20. But again, dendrites is really the most efficient type of a snowfall accumulator that you see forming at that temperature. Now, you do still see ice particles forming at even colder temperatures than -20. You see -25, -30, getting into different types of plates, different types of solid columns, and this gets into very, very, very dry type of snowfall. And so when we start talking about the wet versus the dry snow, if the temperature in the cloud is somewhere, let's say around -7 or 8 to about maybe -12, that's usually going to give us a little bit more of a wetter snow because the cloud is warmer, and the type of crystal that's forming has more moisture in it, more water content. And so that's typically a wetter, more sticky type of a snowfall. If the cloud temperature is, let's say, -15 to -20, we're gonna have a lot of these dendrites form. It's gonna be a lower water content type of snowfall. It's gonna be a drier snowfall. And so as that snow falls, it's gonna be more of that powder that starts to accumulate on the ground versus that heavy, thick, wet stuff. So whether we see the dry snow falling or we see a heavy, wet snow falling really has everything to do with what the cloud temperature is where the actual ice crystals are forming. So when forecasters are trying to predict whether it's a dry snow or wet snow, we're really trying to figure out how much moisture is available in the cloud and at what temperatures is that moisture, going to encounter. So that will determine what type of snowflake that we see form. Now, this also gets us into the next thing that we talk about, which is called snow ratios. So basically here what happens is a drier snow has a higher ratio than a wetter snow. So let's kind of explain this a little bit. A typical snow ratio that you hear that we use quite a bit because it's a very easy number to use is about 10 to 1. And that is pretty close to our typical snow ratio here in the mid Atlantic, about 10 to 1. So that means if you're going to see 1 inch of snow on the ground, there needs to be about 1/10 of an inch of liquid water contained in that snow. So think of it this way that in order to get an inch of snow, that would be equivalent to you seeing or picking up about 1/10 of an inch of rainfall. So a 1/10 of an inch of rain is not a lot of rain. It's just enough to get the ground nice and wet. So it doesn't take a whole lot of what we call moisture or rainfall equivalent to produce 1 inch of snow. And the reason for that is because as water freezes, it expands and ice takes up more space than water does. So as you go from a water droplet to an ice crystal, it expands, takes up more space. So, 1 inch of snow requires about 1/10 of an inch of liquid water. Now, this is only really correct about 25% of the time. Sometimes the ratio is quite a bit lower than 10 to 1, and sometimes the ratio is higher than 10 to 1. Ratios can range anywhere from 3 to 1 and it'll go all the way up to 100 to 1. Now, in our neck of the woods, usually a high snow ratio here would be about 25 to even 30 to 1. Very rarely do we see ratios much above 30 to 1. And so basically the way this works is that your heavier snow, your wetter snow has a lower snow ratio because it has more water content in it. So the more water content in the snow, the lower the ratio. So a 6 to 1 ratio would be a really heavy wet snow. Made great snowballs, great snowmen, but have a high water content and can actually start to freeze into ice pretty quick as temperatures drop below freezing. You know how you can get that crust that starts to form on top of the snow, or the snow compacts, and all of a sudden you go out the next morning, and instead of snowfall, you really have more of a compacted ice layer. And that's in that high water content, low ratio snow. The average around our area is about, I'd say, anywhere from 9 to 1 to about 11 to 1. That's our typical snow ratio. Now, if we're talking about a snow ratio of 30 to 1, which does occur around here, now all of a sudden you're getting into that really light, fluffy snow. Great for skiing, great for sledding. And this is the point where the snow is so dry, you can usually go out with a leaf blower and just blow the car off or just blow off the sidewalk. Because the snow's dry, it doesn't stick together, it doesn't have a lot of water content in it, it's light and fluffy, so it's much easier to move around. where that heavy wet snow at that 6-to-1 ratio, that's going to be hard to shovel. It can be very, very heavy. So the way the snow ratios work is that, the higher the ratio, the more snow you're going to see accumulate. So let's say we're expecting maybe a half inch of liquid. So if this was rain, we would see, we would expect about a half inch of rain. So if we have a half inch of liquid available and the snow ratio is 10-to-1, well, that gives us 5 inches of snowfall. And this would be a fairly heavy, wet, and sticky snow. Be great for snowballs, great for snowmen. Going to be pretty heavy for shoveling, but it's going to be that nice, thick, wet snow. However, if we take the same amount of liquid, let's say it's a half inch of liquid, and now the ratio goes up to 20-to-1, meaning that now it's a drier snow, going to be much more fluffy, great for skiing, easy to get a blow off the sidewalks. Well, that same amount of half inch of liquid with a 20-to-1 ratio gives us 10 inches of snow. It doubles the amount of snowfall accumulation. So even though the amount of moisture in the atmosphere remained the same, because of the snow ratio, the amount of snow that you accumulated in your backyard doubled. So when we're forecasting snowfall, we have to figure out the temperatures at the surface, the temperature in the clouds, and how much moisture is going to be available to make snow. And then from there, figure out what the snow ratios are going to be. And as you all know, a lot of times the snow ratio changes. It may start out as a heavy, wet snow, and it may end as a dry, fluffy snow. A lot of times, if we're going to see snow for several hours, you guys know that you'll actually see the type of snowflake changing outside. And so we have to sometimes try to figure that out. What is going to be the ratio as the event unfolds? So thank you for joining us today for our final edition of Whether You Want to Know or Not. Again, my name's Jeff Orrock. You see my email address there, jeff.orrock@noaa.gov. Keep up with all the latest forecasts and warnings at weather.gov/AKQ. When you're on our website, you can click on that little snowflake icon. That'll take you to our winter weather forecast. Or you can just go to weather.gov/AKQ/winter for all the latest snow and ice forecast. Again, thank you for joining us for Whether You Want to Know or Not.